Okay, so we're going to use the definitions of trig functions of any angle. We're going to use sines of the trig functions. We're going to find reference angles. And then we're going to use reference angles to evaluate trig functions. So, there is a lot to memorize in this thing. So I've got that showing for you. If you're on the Nearpod, you can see it. So remember from section 4.3 that a right triangle formed by drawing a line segment. So we've got a right triangle here. We've got x equals b, y equals a, and r equals c, or c equals r, you know. A, B, and C from a right triangle, and this is P of X, Y. So, from section 4.3, that a right triangle formed by drawing a line segment to a point, X, Y, is perpendicular to the X-axis, just like I've drawn here. Y is the length of the side opposite theta, to be theta, and x is the length of the side adjacent to theta, x, right here. Then r is the distance from 0, 0 to x, y. And so if you use this triangle, you can come up with the definitions. But you don't have to memorize these as long as if you've got, but you do memorize that sine is opposite over hypotenuse. And so looking at this picture, opposite is y, hypotenuse is r. So y over r. So do you even need to memorize that sine is y over r? No, as long as you can draw the triangle. And memorize that sine is opposite over hypotenuse, you can figure this one out. Cosine is adjacent over hypotenuse. So according to the picture, adjacent is side is length is x over, and the hypotenuse is r. Now, in our unit circle part, we had r equal to 1. Now r can be any number. So r is not necessarily equal to 1. It's not the unit circle. Okay? Tangent is going to be opposite over adjacent. Opposite over adjacent, and using my y and my x, that's y over x. And then for these other three, you should have these reciprocal things memorized. Cosecant of theta is 1 over, not cosine, because I just always remember that the first letters don't match. Sine goes with cosecant, and cosine, 1 over cosine goes secant, and cotangent is 1 over tangent. And you do need to go ahead and write the angle down. Okay, so instead of memorizing what this equals in terms of all that, you're just going to flip these. 1 over sine, the reciprocal of a fraction, is r over y. This, we're going to flip that, r over x for secant, and for tangent, it's going to be x over y. And that's how I memorize it. I have these memorized and these memorized. Get these first and then these. Okay? So you need to be able to draw a picture. So do you need to memorize all these? No, if you can draw the triangle and remember these and these, you can get those. Okay. So the next slide is the next example. Oh, of course, we can't let the denominators be zeros, so that's why it says R would never be zero, but that's why it says X not equal to 0, Y not equal to 0, and all that. Okay, so here's an example. We're going to work it on our paper. All right, so that's the point. So we're going to draw a little picture. And we're going to let this one be 1, and we're going to go down to -3. So the point, say 1, -3. This forms, this is actually our theta. And we make a triangle
with the x-axis.
So we're going to always make our triangle with the x-axis. And so here's our x. X is, the distance here is 1. And our y is -3. And then we have an r. We have to find r using the Pythagorean theorem. So, or r is the square root of x squared plus y squared. Is the square root of 1 squared plus -3 squared. That's the square root of 1 plus 9. That's the square root of 10. And I'm going to want exact answers, so you're not going to take your calculator and find the approximate value of square root of 10. You're going to use square root of 10 in all these. Okay, so our sine of theta is going to be y over r is going to be -3 over square root of 10. Well, we need to rationalize that denominator. Square root of 10 over square root of 10 is -3 square root of 10 over 10. Running out of juice. Okay, so that's sine, and then cosine is going to be x over r is 1 over square root of 10, and again, we're going to rationalize that. Square root of 10 over 10. Now, tangent theta, we could do sine over cosine, or we can use these y over x. Y is -3, x is 1, we get -3. So now we found the three of the trig functions, sine, cosine, and tangent. Now we need to find cosecant. And I find that by using 1 over sine. But I'm going to take the sine back here. 1 over is the reciprocal. So I don't want to take the reciprocal of this and have to rationalize it again. I'm going to take the unsimplified version before we rationalize the denominator, and I'm going to take the reciprocal of that. So that's the square root of 10 over negative 3. And you can put the negative sign out front, but that's the answer. Negative square root of 10 over 3. So when you take the reciprocals, you're going to use the unsimplified version for secant theta. I'm just going to do 1 over cosine theta. And I'm going to take cosine theta before we rationalize the denominator, so when we take the reciprocal, that's just the b squared of 10. And then tangent, it's of cotangent theta is 1 over tangent theta. So I can take the reciprocal of minus 3 is minus 1/3. Remember reciprocal, just take 1 over it, or you flip the fraction. Any questions? Okay, review from maybe the first day. What is a quadrantal angle? It's an angle that in the terminal side lies on the x or y axis. And it's in standard position. You have to remember standard position. So its initial side lies where? X-axis. Right, the positive x-axis. Okay? So that's a review of what a quadrantal angle is. Are people still copying this? Okay, so we went through all these slides, but now I just do cotangent and 1 over tangent. I don't have to mess with all that. So we found all those. So we're going to evaluate, if possible, the cosine function. So here's the steps. Back in our notes, I've got the steps written out for how to find the values of the trig functions at a quadrantal angle. And then we're going to find some of them. You're going to draw your angle in standard position. You're going to choose point P on the terminal side, 1 unit from the origin, so I guess we are going to use the unit circle. Unit circle, and that will mean that R will be 1. We're just going to pick, why not just pick R equals 1? Apply the definitions of the trig functions. So, example, we're going to evaluate the cosine function and the cosecant function of the following quadrantal angles. So, if theta equals 0 degrees, or 0 radians. Let's draw a picture. We'll make this the point 1, 0. And there's really no triangle to draw. We have r equals 1. This is x comma y. So cosine is x over r. X is 1 and r is 1, and we're going to get 1. Did that make sense on the unit circle? Cosine is the x value. And we get that. Cosecant. Well, cosecant theta is 1 over sine. Or I could use the definition, but sine is y over r, so I've got 0 over 1 is 0. So cosecant is 1 over 0. You have to flip that. And so it's undefined. So you can either use, or you could have said that cosecant theta is r over y. And that was 1 over 0 again. So you can use these definitions if you want, or you can, this is the way I like to do it, sine. And remember on the unit circle, y is just sine. 1 over sine is cosecant. Okay, the next slide. Okay, I'm going to move the slideshow if you want to, if you have that up, you can be looking at that while we work the problem. Might help you to see that. Theta is 90 degrees, so we're going to draw a picture, or pi over 2, and this is the point 0, 1, so that's our x, y, and then r is again 1. This is theta. It's 90 degrees. So cosine theta is x over r. 0 over 1 is 0. Let's just find sine, and then we can find sine theta is y over r is 1 over 1 is 1. Now we can find cosecant using, we can do 1 over sine. That's the way I like to do it. Is 1 over 1 is 1. So that's how you can find the trig functions at the quadrantal angles. And we can keep going. Slide.
Quick question. I'm a little confused on where we're getting the units from. The coordinates 0, 1.
Oh, okay. We said we would pick P to be on the unit circle. We'll just pick it to be 1 unit from the origin.
Okay, so y and A is the x value 1, and B the y value is 1.
Okay, well this is the angle, 0 degrees. Means you start at the initial side and you go 0.
Okay. Gotcha.
So the coordinates is 1, 0.
Okay.
Here you're starting at your theta starts at its initial side, the positive x-axis, and goes to 90 degrees.
Gotcha. So if it was 180, it would be -1.
Right, and
Okay.
so we're going to do those.
Okay. Thank you.
So we start at this initial side, and our angle goes to here, and we're going to use the point -1, 0. So cosine theta is gonna be x over r. R again is 1, x is -1, is -1. I'm finding sine so that I can find cosecant easily. It's y over r, and y is 0, 0. So cosecant theta is 1 over sine, again, is 1 over 0, is undefined.
So R is always 1?
Yeah, we're picking r to be 1. We could pick r to be 2, but it's just convenient to pick r 1. We're choosing to use 1, the unit circle. Okay? It said we're just going to choose the point P to be it. If we chose 2, we would have 2 over 2 equals 1. If we chose 1.5, we'd have 1.5 over 1. So we get to pick point P, so I guess you may be getting confused because R can be any number, but on the second page, if we have a choice, we'll choose 1. R can be any number, but we're going to choose 1. We're choosing 1 on the second page, so it's on the unit circle. Because we really like our unit circle. So, if we chose 2 for it, these things would still come out the same. You can put in 2. If we chose the point 2, 0, x would be 2, r would be 2. And you still get 1 for cosine. So we're just picking r to be 1 on the unit circle. And then the last one is, so you start, this is standard position, here's your initial side. We're going to go to 270, theta is here. 270. And this point is going to be 0 minus 1. And then, so that means that x is 0, y is -1, and r, because is 1. We picked r to be 1. We find cosine. You can't really make triangles with these, so we're just going through these. Cosine is x over r, 0 over 1 is 0. Sine, we're finding sine, even though it didn't say to, because I like to do that. Y over r is -1 over 1 is -1. So that means cosecant theta is 1 over sine theta is r over y, or you can do r over y if you want and not do the second one. It's just 1 over that, 1 over minus 1. So using our point P, and you can try choosing P in 2 units when you work, and you're going to get the same numbers. Any questions? Okay. Okay, so those are the examples. And there's a slideshow. So we're on the next page, and we've got the signs of the trigonometric functions. Let's see, what's 7? Okay, so I do have to fill in number 7. Point 7 is if theta is not a quadrantial angle, the sign of the trig function depends on the quadrant in which theta lies. So, the signs of the trig functions, so the positive functions in each quadrant, in quadrant 1, remember the quadrants are 1, 2, 3, and 4. Okay. Quadrant 1, all of the trig functions are positive. In quadrant 2, sine and cosecant are positive. In quadrant 3, tangent and cotangent, the rest are negative, are positive. In quadrant 4, cosine and secant are positive. I just wrote it out these. And you can remember that with a smart trig class. A smart trig class. Or all students take calculus. Whatever you want to remember it with. Or maybe a smart trig class. You guys want to be a smart trig class and remember this. But if you can think about the unit circle, you know, x represents cosine, y represents sine, and so when you're in quadrant 1, both sine and cosine are positive, so everything's positive in there. When you're in quadrant 2, x is negative, so cosine is negative. As soon as cosine is negative, see, this is cosecant. This is CSC. This is sine. This is tangent. This is cotangent. These are the abbreviations. Cosine and secant. Okay? So you can think out or remember that a smart
Trig class gives you the signs, or all students take calculus, whichever one you prefer.
So, let me show you the, so here's the slide, all, or a smart trig class. All functions are positive, that's, so here we go. You gotta memorize that. Oh, you get to do a little fill in the blank if you want to, but and then I did add something into this, and it had the answers up there. If you're in this thing, which you don't have to be, but I think it helps, you can do that. So I used a smart trig class because all students don't take calculus. So. A smart trig class. Here we go. All right. Oh, went back to this. Oh, okay. Oh, this is the next example. So down at the bottom of the page, we're going to do an example. So find the quadrant in which the angle lies. So if sine of theta is less than 0, that means sine is negative. and cosine is negative. Which quadrant has a negative sine and cosine? Well, sine is, on the unit circle is y, and cosine is x. So where are x and y both negative? That's quadrant 3. So you can also just think about cosine being x and sine being y. Where are x and y both negative? Quadrant 3. So, or I drew the picture, but. Alright, so we're going to evaluate some trig functions. So, the next example, I guess, we'll show the slide. There it is. Okay, so given tangent theta is minus 1/3, that means tangent is negative. And cosine is less than 0, that means cosine is negative. Okay, so where is tangent negative? Tangent is sine over cosine. So tangent is negative in the second or the fourth. But which quadrant would we be in if cosine is also negative? Cosine is x. It's positive here, so cosine. So we're in quadrant 2. So this tells us we have to know what quadrant we're in. This tells us we're in quadrant 2. All right. Now we'll draw a picture, bigger picture. Okay. And it says that tangent, which you have to remember, is minus 1/3 is opposite over adjacent. So we're going to draw a triangle. Right triangle. Make this -3 and make this +1 in order to be. So I'm going to have to move this negative sign in order to be in quadrant 2. You know, this is my P is going to be -3, 1, the point. There's my triangle. We have to make cosine x negative. Your cosine is negative. We have to move this negative sign to be in quadrant 2. Here's our theta. By the way, this is called a reference triangle. We'll get to it in the next thing. Okay, that's our reference triangle. So we need to find R, and we can use the Pythagorean theorem that R is the square root of x squared plus y squared. Our x is -3, our y is 1. So we can find R, and again, it's going to be square root of 10. Nine plus 1 is square root of 10. Okay? R is square root of 10. And then now we can find sine. You can either find sine is this is we're going to sine is going to be y over r 1 over square root of 10, and then we multiply that by square root of 10 over 10 square root of 10. And you get square root of 10 over 10. Find secant. So secant is 1 over cosine, which is, cosine is x over r, so we're going to have r over x. If we want to do it that way, is r is square root of 10, x is negative 3. We get negative square root of 10 over 3. Okay. Okay, so now that's, and we got the right signs for sine and secant. Cosine was negative, so secant will end up being negative. But often when we evaluate trig functions at positive angles greater than 90 degrees and all negative angles by making use of a positive acute angle, this is called a reference angle. Reference angle theta prime. And in this picture, it would have been right here. The reference angle is the positive acute angle. Remember, an acute angle is between 0 and 90 degrees. Theta formed by the terminal side, and the x-axis. It doesn't have to be the positive x-axis here. This would have been our reference angle right here. That little one right there. Theta prime. And there's, so.
How do you know to draw the triangle like that? I'm confused on how you do that.
How do I know to draw it here instead of here?
Yeah.
Because I was already using, we're going to use reference angles later. So you're going to want to draw your triangles against the x-axis. That's what I've been doing. So I've been using prior knowledge that I knew we were going to do this.
But since it says like cosine is less than 0, so that means
Oh, okay, you're on the next step, or what? Are you asking?
I'm just confused on how you know it's supposed to be in the second quadrant.
Oh, this one. Okay.
Yeah.
Oh, okay. Well, tangent is going to be negative. Remember, you got. Do you understand how tangent is negative? Tangent is sine over cosine. In quadrant 2, let me. So you're going to have to get used to quadrant 2. You remember, if we have an x and a y coordinates, you're going to have a negative x and a positive y. Well, remember that x is cosine of the angle and y is sine. That's from the unit circle, for the unit circle anyway. And so, then tangent, tangent is sine over cosine. So as long as these are opposite signs, sine and cosine are opposite, tangent will be negative. So tangent's negative because you're going to take a positive number divided by a negative and get a negative. So tangent is negative in quadrant 2. And they tell us that cosine is also negative. And so this is quadrant 2. Does that make sense?
Yeah.
Okay. And so, yeah, and it depends on you remembering this stuff, but, I'm just showing it to you in terms of x and y, maybe to simplify it, but the x and y are both positive in this quadrant, negative and positive, negative, negative. So you take a negative divided by a negative and tangent will be positive, and then this is positive, negative. These are the signs And remember that x is cosine and y is sine for the unit circle anyway. So, and then when you take over it, okay? All right, and then let's go back. So they went through all this on the slides. Okay, so this is the next picture. There's the pictures all ready for you. So if you've got if your theta is over here somewhere, then your theta prime, you're gonna do it against the positive x-axis, so that'll be your reference triangle. So you want your theta prime to be 180 degrees minus theta. This is 180. This is your theta prime. 180 minus the theta. That's your reference angle. Sorry, you can't see that. The reference angle, theta prime. You have to memorize this. The reference, there's so many things to memorize. Sorry. Reference angle for 180 to 270. So they got a picture there. It's always with the positive x-axis. So if your angle is in here somewhere, you're going to make your reference triangle against the x-axis, and that's going to be your theta prime. Theta prime then would be 180 plus, let's see, it's going to be theta minus 180. Sorry. You just always going to make sure that theta prime is positive. And I think you're just going to draw a picture and see what it is. And then if you happen to be in the fourth quadrant with your angle anywhere in here, you draw it here. This is theta, this whole thing. So you need to take 360 degrees and subtract theta. So then we just have practice finding the reference angle. So here's the practice in finding the reference angle. So theta prime. So just draw the picture. If theta is 210 degrees, that's 30 degrees beyond 180. This is 180. This is 210. This is 30 degrees. We draw our triangle here. This is our theta prime. You can just see that it's 30 degrees. You don't have to do 210, you don't have to do theta minus 180. You can draw the picture and figure out your angle instead of memorizing these things. Draw the picture. This would be 210 minus 180 is 30. So you don't have to do this. You can just draw the picture, figure out what that angle is.
Did you go up to the picture? Scroll. I need to draw one more picture from the previous point.
I want to, do what?
I just need a picture from the previous section real quick. 13A or whatever. Yeah, there. That's perfect.
It's up there.
Sorry.
It's not very nice picture, but
Okay, that's perfect. Thank you.
Better than nothing.
okay, all right. Okay, and so I'm just going to draw the pictures. So if you get an angle given in pi radians, then you're going to leave theta prime in radians. We're not going to convert everything to degrees in this class. So here, just draw the picture. You need to be able to count in the pi. So this is pi over 2. This is pi, so what's 7 pi over 4? So this is 3 pi over 2. 7 pi, this is a little harder. 7 pi over 4 is there. We need to draw a reference triangle against the x-axis. This will be our theta prime. Theta prime is going to be 2 pi minus 7 pi over 4. We're going to rewrite 2 pi as 8 pi over 4 minus 7 pi over 4. So theta prime is pi over 4. So I saw for the picture that I needed to take 2 pi minus 7 pi over 4. Draw your picture for negative 240, negative 90, negative 180, negative 240s over here. There's our theta. Now we need to go to the x-axis, our theta prime, that angle. What's that going to be? It's just going to be, what did I do? I took the absolute value of minus 240 plus 180. Or you could figure it out from the picture what it is. It's going to be 60 degrees. Theta is 3.6. This would be in radians. Okay? So, and 3.6, well, pi radians is 3.14. And this is 4.71, this is 3.14. So 3.6 is somewhere over here. So this is going to be our theta prime. Theta prime, we're going to take this angle, 3.6, and subtract. Theta prime is going to be 3.6 minus pi. Or approximately, if we use 3.4 pi, 0.46. Okay. Now we're going to stop there, and we will do as much as possible on the review. But we're going to finish this next time. There's 3 worksheets, 2 worksheets, one worksheet due next time, and one on Friday. And remember, I'm going to give a quick quiz on the memorization. I showed it to the class. Memorizing. I've got the exact quiz posted so we can So if we go all the way down, trig identity quiz practice. This is what it looks like. It's exactly like that. You're going to have about 5 minutes, so you'll have 7.5 minutes to write down that stuff. You're going to have that memorized.
Oh, okay.
For next time. Yes.
I was just gonna say, I just came in. I don't think you probably marked me absent.
No, I did mark you absent.
Yeah.
When did you get here?
I got here like, I don't know, 40 minutes ago or so.
Oh, okay.
Yeah.
Okay.
How about me?
All right, it's just hard to get up.
I know, yeah, I understand. Me?
We stopped it.
Where is it? Did you mark me absent too?